So 2.6, the last section in Unit 2, we're going to talk about linear programming. And this section is going to be covered over a handful of days, as it does take some time to figure out totally. So if after watching this video the first time you don't totally get it, that's okay. We're going to practice together as well. So we are going to, for linear programming, we are going to write constraints and objective functions for linear programming problems. And then we're going to maximize or minimize a quantity using linear programming. And you might be asking yourself, what is linear programming? So it's a method for finding a minimum or maximum value of some quantity given a set of constraints. So if I look at the graph to the right here, these are my constraints. In this situation, there are 4 inequalities that make up those constraints. And then we see on the graph, we end up with what we call is a feasible region. So again, the constraints form a system of inequalities. For most of what we're looking at, it's going to be 2. This picture does show 4. The feasible region is the graph of the system, just like we did in 2.5 where we graphed these inequalities. And then the objective function, which you see up here, models the quantity you're trying to maximize or minimize. And that's how we're going to actually answer the problem. So again, this may seem like a lot at first, but we'll walk through it. Our first step is going to be to define our variables. So again, similar to what we did in 2.4 when we were looking at word problems and we talked about what is X, what is Y, we're going to do that same thing here. Then we're going to write our constraints, which are inequalities, in our objective function. We're going to graph the constraints. Once we have those done, we're going to find the vertices of the feasible region. Using the vertices, we're going to evaluate the objective function, and then we're going to use the information we get there to answer the question using complete sentences. So let's just preview what it would look like to create constraints for one of these situations. So number 1 says you have to complete at least 15 physics problems and math problems within 2 hours before you can play video games. So I'm going to highlight at least 15 physics problems and math problems within 2 hours. That information seems like it's going to be important. It will take you 10 minutes to complete a physics problem and 6 minutes to complete a math problem. So let's look at our choices here then. So I need to complete at least 15 problems, which means I can answer more than that, but I can't do less than that. So let's say X is physics and Y is math. That would mean X plus Y should be greater than or equal to 15. So I can cross out A for sure because I'm definitely not subtracting those. Then I have to look at between B and C, which one shows at least. That's the key word there. That's looking like it's going to be C, but let's check the second inequality as well. It says 10 minutes to complete a physics problem, so that would be 10x, and 6 minutes to complete a math problem, so that would be 6y, and I have to do it within 2 hours, which is 120 minutes, and so it would be less than or equal to that, so C is the correct answer. Okay, if I look at the second one, it says you can work a maximum of 40 hours per week. You need to make $400 in order to cover your expenses. Your office job pays $12 an hour and your babysitting job pays $40 an hour. So let's start by figuring out what our variables are, because that will help us with the rest of this. So it looks like we have 2 different types of jobs. So let's say that X is an office job and Y is babysitting. Okay, So I can work a maximum of 40 hours a week. That means I would have to work no more than that, right? So anything would have to be less than or equal to 40. So I think we can cross out C. Oops. We can cross out C right away because that's saying greater than or equal to 40, but we can't go over 40 hours a week. So that one won't work. Um, Now, if I look at B, that's saying X minus Y is less than or equal to 40, but we're adding together the time that we spend at these two jobs. So let's cross off B also, but let's double check that A works for both. So X plus Y has to be less than or equal to 40. We agree with that. Now it also says your office job pays $12 an hour, your babysitting job makes $10 an hour, and I need to make 400 at least in order to cover my expenses. So that would be 12x, looks good, plus 10y, looks good, greater than or equal to 400. So A is the correct option. Okay, let's try one on our own. So Lisa has an online jewelry shop where she sells earrings and necklaces. It takes 30 minutes to make a pair of earrings and 1 hour to make a necklace. And since Lisa is a math tutor, she only has 10 hours a week to make jewelry. In addition, she only has enough materials to make 15 total jewelry items per week. She makes a profit of $15 on each pair of earrings and 20 on each necklace. How many earrings and necklaces should Lisa produce to maximize profit? So, a couple things we need to think about here. We're going to write the constraints and an objective function. I think sometimes it's easiest to start with the objective function, or at least to figure out what that's going to look like. And we want to maximize profit. So our objective function is going to be how much money we can make. So we have two variables here. And so let's actually define those before we write our profit. She sells earrings and necklaces. So let's say X is earrings and Y is necklaces. And so what we're trying to do is make the most amount of profit that we can. So our constraints have to be based on what she's talking about in here. Okay, so it takes 30 minutes to make a pair of earrings and 1 hour to make a necklace. And she only has 10 hours a week. So let's write this first constraint in terms of time. So it would be 30 minutes, which would be, we'll leave this in minutes. So 30x plus 1 hour, which is 60 minutes, y. And she only has 10 hours. So we can't go over that 10 hours, which means this has to be less than or equal to 10 hours, which would be 600 minutes per week. And then she only has enough materials to make 15 total jewelry items per week. So that means the number of earrings plus the number of necklaces has to be less than or equal to 15 because that's all that she has the materials for. So there's my two constraints. And now let's go back to my profit. So my objective function, I make a profit of $15 on each pair of earrings and $20 on each necklace. So $15 per earrings and $20 per necklace. Okay? So again, here's my constraints. And then blue P is my profit. That's my objective function, 15x plus 20y. Let's do one more practice here. And then our next step will be to graph them. But you're going to do some more practice with just writing these before we get to that. So your school has contracted with a professional magician to perform at the school. The school has guaranteed an attendance of at least 1,000 and total ticket receipts of at least 4,800. The tickets are $4 for students and $6 for non-students, of which the magician receives $250 and $450 respectively. How many student and non-student tickets should be sold to maximize profit? Okay, so again, if we're looking at our objective function, what we're looking for there is the profit. So we can come back to actually write that, but that's what we want out of this. We want to know, how can I make the most money? So let's go to our constraints. Actually, step back here. Let's do our variables. So we have two different types of tickets. We have student tickets. So we'll just call that X, and then we have non-student. So we'll use Y for that. Now we can write our constraints. So the school has a guaranteed an attendance of at least 1,000. So that means students plus non-students has to be at minimum. So it would be greater than or equal to 1,000, right? Because they've guaranteed at least 1,000. And then I'm going to sell tickets $4 for students, $6 for non-students, and I need to spend at least, or yeah, total ticket receipts of at least 4,800. Okay, so again, I'm going to do 4x plus 6y, and then at least translates to greater than or equal to 4,800. There's my two constraints. Now let's look at our objective function. We're going to look at the profit. And so the magician receives 250 and 450 respectively. So it would be 250 for students plus 450 for non-students. So variables right here, constraints right here, objective function there. You guys are going to do some more practice with this, and then we will talk about how we graph and actually solve these in our next video.